Hello folks, this is going to be a short screencast. This is just the end of solving trig equations. Let's take a look at a quick example here of solving a trig equation that I've got on the board here on the interval from 0 to 2 pi. Now, one of the things that I didn't stress enough in class today that I'm going to stress more now is when you solve a trig equation, you want to take the same approach to it as you do a quadratic. You always want to start by making one side 0. So the first thing I'm going to do is I'm going to subtract sine squared across. Okay? Now when I do that, I get negative cosine squared of x minus sine squared of x. I always like to put my exponents first. Minus cosine of x plus 1 equals 0. Now here's my dilemma. I've got sines and cosines in this problem, right? They're not compatible. Well, we need to make all the words match in this problem. So what I'm going to do is I'm going to use those trig identities that you guys have been practicing. Would you agree that the dominant word in this equation is cosine? There's a cosine squared, there's a plain cosine, versus there's only a sine squared of x, right? So there are more cosines than sines. So it's going to be easier for me to just convert this sine squared into cosine. Well, if you remember from your trig identities, sine squared is the same thing as 1 minus cosine squared of x. Agreed? Right? And because of that, I would get negative cosine squared of x minus 1 minus cosine squared of x, and then minus cosine of x plus 1 equals 0. Well, now that I've got the same word, cosine, let's see if I can combine some like terms and simplify. I get negative cosine squared of x minus 1 plus cosine squared of x minus the cosine of x plus 1 equals 0. Oh, wait a minute. I can combine some like terms here. The negative cosine squared of x and the positive cosine squared of x cancel. The negative 1 and the positive 1 cancel. And I'm left with negative cosine of x is equal to 0. This is a very sad mappable equation. I would divide the negative across to get rid of that. I get cosine of x still equals 0, because the 0 divided by negative 1 is still 0. Doing the inverse, I say x equals the cosine inverse of 0. Well, where does cosine equal 0? I know it's at the quadrantal angles up here and down here. So I know that's the quadrantals of pi over 2 and 3 pi over 2, right? Now the question is, should I put in plus 2 pi n down here or not? Well, again, if you think about this, didn't we say that I was going to solve it only over the first cycle? So we know that you don't put the plus 2 pi n. That should not be written, okay? Moral of the story, this example just shows how I can rewrite sine squared in terms of cosine squared to make it easier to solve, okay? We'll talk more about this tomorrow.